Good morning, everyone. This is Ms. Hart back with another Math Bellringer. This morning, we'll be exploring solving a system of equations by elimination. Two typical ways you can solve a system of equations in algebra. You can solve it by substitution or elimination. Those are the two typical ways. But this morning, we will try to focus on solving this by elimination. Elimination means I want to cancel one of my variables being x or y. So let's see what we have here. We have 1x. By the way, this will be an understood one. I just went ahead and put the 1 there. 1x minus 7y equals to 18. And we also have 4x minus 14y equals to 30. So if I look at all 6 numbers I have, meaning I have a 1, a 7, an 18, a 4, a 14, and a 30. I want to eliminate the smallest number, either negative or positive. It just has to be the smallest number. The smallest number on the board is a 1. Okay, without looking at positive or negative, the smallest number is a 1. So what I want to do is I want to eliminate this 1 somehow. This is how it works. I can take this 1 and turn it into a 4. I need a positive and a negative of the same number. So I can have a positive 4 and a negative 4. Because I already have a positive 4, I can take this 1 and turn it into a negative 4. So in order to do that, I need to ask myself, okay, so what can I multiply by 1 to get negative 4? That would be negative 4 itself. This is how it works. Because I'm now multiplying the 1 by negative 4, I must multiply this entire equation by negative 4. I'm going to say 1 times negative 4. I'm going to say negative 4 times negative 7. And I'm going to say negative 4 times 18 there. So I will now begin multiplying. So 1 times negative 4 is negative 4. Negative 4 times negative 7 is positive 28. 18 times negative 4 is negative 72. Now, after you have multiplied either of your equations by any number you chose, you now use the new equation and the other original equation, meaning that I will now use these two equations. I will use the 4x minus 14y equals to 30 with the negative 4x plus 28y equals to negative 72. These are the two I'm using. And as you see, I achieved what I wanted to achieve. I have a positive 4 and a negative 4. They will eliminate each other. Okay? So I'm just for face value, I will just go ahead and cross them out because they eliminate each other now. And now I want to add or subtract the rest the way I see it, meaning that I see a negative 14 with a positive 28. That means I'm going to say negative 14 plus 28, which is going to give you a positive 14. And then don't forget to bring down the variable that's attached to it. The variable attached to it is the y. And now I see 30 minus 72. Why minus? Because it's a negative 72. So now I'm going to say 30 minus 72. That's going to give me negative 42. And in this particular case, your last step would be to divide. You want to divide by the number with the variable. So I will be dividing by positive 14. So if you were to say negative 42 divided by 14, you would get a negative 3. And now it's called a system for a reason. System means that we have to solve 2 of these. Okay? So what I want to do now, I want to take this y, which is equal to negative 3, and I want to plug it back into either of my original equations. At this point, it doesn't matter. So it's up to you to choose. I like to choose the one with the smallest numbers to make it easier on myself. So it's either going to be the first equation or the second equation. Okay? I'm going to go ahead and go with the first equation because a 1 is smaller than a 4. A 7 is smaller than, actually, no, it's not. I'm sorry. A 1 is smaller than a 4, and an 18 is smaller than a 30. Sorry. Okay. So these have the 1 and the 18. I'm going to go ahead and plug it into there. So now it says y is equal to -3. So be careful. That's where you want to plug the -3. You want to plug it right there. You want to plug into the -7y. So now I'm going to rewrite this equation with the -3 instead of the y. And I know a couple of weeks ago, I introduced to everyone my peanut butter and jelly method. Now, peanut butter and jelly method, there are usually two sides of the equation. So if you can make the analogy, two sides of the equation means two slices of bread. And then you're adding or subtracting on each side with a final division. Okay, so that can be spreading the peanut butter and spreading the jelly. Peanut butter and jelly method. Okay, so from this point on, it's just regular peanut butter and jelly. So now what I see is I see a number beside a parentheses. I want to multiply. That's what a number beside a parenthesis means. A negative times a negative is a positive. And as you see, it says -7 times -3. That will give you positive 21. And then continue to bring down what you did not use yet. I did not use this 1x. I did not use this 18. Okay, I continue peanut butter and jelly method. Now it works like this. I want to combine like terms. You want to combine the things that look alike. So let's think about that for a second. I have 1x, and then I have a 21, and then I have an 18. 21 has no variable, 18 has no variable. So for face value, they look alike, if you may, okay? Because they both have no variable. So I want to combine those. Peanut butter and jelly states, whatever they're doing, you want to do the opposite. So what I want to do is I want to move the 21 to the 18. They are adding the 21. I want to subtract the 21. And then I am left with 18 minus 21. That will give you a -3. And then now I have one more thing left I did not use. I did not use the 1x. I will bring it down now. So it's right there in the corner. And now, the very last step of all, I want to divide. I'm going to divide by the number with the variable. So it looks like I'm going to be dividing by 1 in this case. So if I were to say -3 divided by 1, I will get -3. And then I ran out of space on the board, so I guess I'll write the answer here. So the system of equations is now solved. You have x is equal to -3, and you have a y is equal to -3. I know that took a while, but that's how system of equation works. Thank you so much. I hope everyone have a good day today.